so we've developing the law of cosine. So we get that, and then here in this group, I'm gonna factor out a b squared. And the reason I'm doing that is because I want to end up with this. This is from chapter 6. That is one of my special identities. Does anyone remember what that happened to be called? Sine squared plus cosine squared. Do you remember what that happened to equal? 1. Yeah, it equals 1. That's my Pythagorean identity. So this whole thing just equals 1. And so I get b squared plus a squared minus 2ab cosine of c. And that would be what this length AB, or this length of c squared, is equal to. And that, ladies and gentlemen, is the law of cosine. Wonderful. So here they are, the three of them, depending on where you're at, what angle you're hanging out at, or which side you're trying to find. Now, there is a relationship. There's always this relationship. The side that you're trying to find and the angle, they always go together. So if I have an A, I've got to have an angle A. If I have a B, I've got to have an angle B. Right? So A squared equals B squared plus C squared minus 2BC cosine A is one of the laws of cosines. Second one, the B squared equals A squared plus C squared. You notice this relationship too? I think helps to remember what it does setup-wise. So if you have A squared that you're looking for, B and C need to be a part of the thing that's attached to the cosine. So look at the second one. I'm looking for B squared. A squared, C squared means those two have to be A's. And then the C squared, that means B and A have to be attached to the cosine. So there it is. You're going to have to just commit that one to memory. And there are the two configurations. Again, having a majority of sides known, 3 sides here or 2 sides, is when I will use the law of cosines. All right, so there's the derivation of it. Again, I just need you to know what they are so that we can use them. So flashcarded, put it on your formula sheet, the back of your notebook, whatever you guys have. There are my laws. And I don't really need to write all 3 of them down. You could really get by with just writing the a squared equals b squared plus c squared minus 2ab cosine c. And then just remember that if I'm looking for other parts, I just switch my variables around. So you don't really need to write all 3. All right. So now let's see. Are we good? So now let's see how we use them. So I could use law of cosines just like law of sines. So law of sines, I can use it to find an angle. I can use it to find a length. And the same thing can happen with cosines. Yes? Oh, why did I do all this stuff up here? To dazzle you. All this was just showing you where the law of cosines comes from. But again, I don't need you to know how to derive it. I don't need you to know how to do that. I just want you to know how to use them. Okay? Alrighty, let's go use them. So now what's going to happen, you're going to have some problems, and you're going to be given, find the unknown values, solve the triangle, something along those lines. You're going to have to determine, based on what the triangle has been given, what sign or what law you have to use. Is it a law of sines problem? Is it a law of cosines problem? I will not tell you which one to do. You determine that on your own. So here, I have a side. Stuck in between the sides is an angle. So this is the situation where it's an SAS, included angle, versus an A, where it's not included, like an SSA situation. That would be the angles on not in between the 2 sides that are given. But here we have an angle in between the 2 sides that are given. So this is our side equals side setup, which now allows me to go find, in this case, just the x. But I could find angles and other things. Is that a hand over there, Paul? All right. So let's talk about how we go find this x here. And I'm just going to show you can just simply always use this ABC thing. And not have to worry necessarily about always switching my variables. All right, in this problem, in the a squared equals b squared plus c squared minus 2bc, in the law of cosine setup, when you have two sides that are known, those are the sides that are going to be representing these b and c values. So 9 and 4 are going to be these b and c values. And a, which is the side we're looking for, is like our x. So if I set it up that way, then this becomes x squared is equal to 4 squared plus 9 squared minus 2 times 4 times 9 times the cosine of, and remember, these always go hand in hand. That means I have to have the angle across from the side I'm looking for, and 110 is across from the side that I'm looking for. So that's what this goes right there. Amazing. All right, so then we take 16 and 81 minus, we got 6, we got 8, 9 minus 72 cosine of 110. So be careful now how we put this in the calculator. Don't try and do it all at one time, because you're going to probably make a mistake. What I would do is I would put in cosine of 110 first, get that number, and then times 72. That's what I would do. So somebody's going to tell me what that number is. Cosine of 110 times 72. 24.62. All right. Because here's what people do when they have brain parts. They do stuff like this. Add, subtract 72. Is that following the order of operations? No, because that 72 is a coefficient that's multiplying. It's a factor over there. I can't do that. So don't do that. So now we can say 16 and 81 is 97. And then 97 minus 24.62 is going to be what? Would what be plus?
Oh, I did cosine 110 times 72. I got it.
Oh, it's a negative?
Yeah.
Oh, okay. All right. Sorry, I didn't hear you say that. Yeah. So you're right. There should be 97 plus 24.62, or we get what? 121.62?
Yeah.
Okay. Yeah. Now that's just what x squared is, which means I have to square root. Now, when I take a square root, I get two answers, but can you have a negative sign? No. So I'm going to get 11 point what? 0.02? 0.03 roughly? All right, and we don't know what the units are. It doesn't say in feet or inches or whatever. But there you go. There's the length of x. What's that? Does that help, Kristen? Yeah? Does that make sense? Okay, now what if we were looking, so that one was looking for a side, but we're looking for an angle. We got to tweak the law of cosines equation a little bit if we want to find an angle. So let's try one of those. Here we have a triangle that has three sides. So this is the side situation. And we want to find the smallest angle. Oh, and then a new word. Well, maybe not a new word, but a word we need to remind ourselves about. The median. That's part B. So drawing our little sketch. We have a 6, we have a 12, we have a 15. There's my triangle. Go ahead and just label your vertices, A, B, C, or whatever. Doesn't really matter what you call them. And now we go, and we set this thing up. So I'm looking for the smallest angle. Okay, by looking at the triangle, actually I don't even need to look at the triangle to know this. Where does the smallest angle always have to be across from? The smallest side. All right, so we know that 6, the smallest side, means that angle C is what we're going to call it. It's going to be our smallest angle. All right, so we set this thing up. So we're going to write it C squared is equal to A squared plus B squared minus 2AB cosine of C. Now, unlike the last problem where we were actually looking for C squared, we're not looking for that anymore. What are we looking for? Cosine of C. We're looking for the angle. We're looking for this. So now we have to rewrite this equation to get that by itself. There are two ways you can do this. You can start plugging in everything for A, B's, and C's and then just get cosine by itself that way. Or, before you start plugging things in, you can isolate cosine of C, just like you would for solving an equation. Move everything to the other side, get that by itself, and then just finally take an inverse cosine and then you'll have your answer. So we're going to do it that way because I want you to see what it looks like when you're solving for the angle. We're going to isolate cosine C, which means A squared does what to get over here? And so does B squared. And what does negative 2AB have to do? It does? It divides. So first of all, it looks like this. C squared minus A squared minus B squared. This is before we deal with it. Is equal to negative 2AB times the cosine of C. We now have to undo that multiplication. And then this is what you get when you're looking for angles for a log cosine problem. Cosine of C is equal to C squared minus A squared minus B squared all over negative AB. Now you could either go one step further and solve for the angle C, which means you're doing the inverse cosine of this stuff. And then that will be my answer. So why don't we plug all this stuff in? We're going to take the inverse cosine of, what was my C? So you got to get this one right. The C squared is important. The A and B, not so much. C squared, the side across from the angle you're looking for, is the C squared part in our example. So we're talking about that being a 6. 6 squared minus 12 squared minus 15 squared all over negative 2 times 12 times 15. Now you can see how you might get yourself confused if you put the wrong things in for A, B, and C there. Right? So be careful when you're choosing A, B, and C. We put all that in, we get 36 minus 144 is what? Negative 108 minus another 225, negative 208, negative 233, all over in negative 360. What do I get? Inverse cosine of that thing. Yeah, do the inverse cosine because we're looking for the angle C. So the inverse cosine of whatever I said, 36 minus 144. Negative 108 minus 225, negative 308, negative 333 over 360, isn't that right? Did I do that right?
Wait. Oh, I forgot to multiply by 6.
Oh, that should be doing inverse of that. Inverse of that. Are my numbers right there, guys?
Yeah.
Okay. So what do we end up with? What is CE? 66 point. All right, let's just go to 10. 66.7 degrees.
Wait, I got some.
You get something different?
Hold on, let me try it again.
Okay. Do we get confirmation on that, people? Okay.
I got 22.3.
C squared what?
I got 22.3.
No, C is 6. C is across from the angle that we're hanging out and we're trying to find. Yeah, you got it? If you misplace the value of C into this equation, yeah, you're going to get the wrong answer.
I got 22.
22.33?
Yeah.
Okay, 22.3 degrees. So just be careful when you're plugging in all your side information. So there we are using law of cosines to find an angle versus finding a side. A little bit more work involved. Just being careful with choosing my length portions. All right, that's answer to part A. What about part B? What's the length of the median to the longest side? So definition of a median, do we remember what that is? The middle, yeah, it does something to the middle. That's true. If we talk about data, set of numbers between the middle is yeah, we're not looking for that. But that's geometrical, actual definition of a part for this triangle. The line. Median is a line. Okay, it goes to the center of the opposite side. So it says we're going to the longest side, which is 15. It's coming from B, and we're going to go intersect at the midpoint of that line segment. That is a median. Not an altitude, which is a perpendicular line to an opposite side. That's different. So I'm looking for that as the median. Now when I do that, I split this length into half of what it normally is, so 7.5 on either side. So is that easy? So if I know that that's 7.5, here let's take out that little triangle. Triangle A, B, and median. And let's see what we can find. So that's going to be a 6. This is going to be a 7.5. It would be nice to have some information regarding an angle in here. I don't have an angle in here, so I got to go find some information to get an angle so I can set up one of my laws. Because it wants to find this length. So I'd love to be able to have, if I could, I'd love to have that angle right there. Anyone have any ideas how we can find that angle A? Yeah.
Why didn't we just do the other side?
Oh, brilliant idea. Why don't we use the other side of the triangle because we already have C. That is a fantastic idea. Look at that. We know this is 20, what did we say it is? 22.3? 22.3 degrees, and that's 12. So look at, that's nice. Side, angle, side. So here's where you have a law of cosines helping you find an angle. And now we have a law of sines. Do we have a law of sines?
Yeah.
No. I'm going to have to set up a law of cosines. Whoa. The queen beckons. Yeah, I need to have some information with regards to an angle B or this angle here, and I don't have that. So we're going to have to set up a law of cosines again, this time for a median squared. Now we'll say median squared is equal to 12 squared plus 7.5 squared. Found all that angles, and now we go and we find this length that we need. Now sometimes what happens is you use a law of cosines. It gives you enough information to then go use a law of sines to find another missing part. But in this case, we would need another either angle B, we would need to know that angle, or we would need to know this angle to be able to use law of sines. So we just go ahead and set up for, there's my relationship of a side that's unknown and an angle that's known. So we would set up law of cosines again. All right, what are we going to get? 144 plus 56.25 minus that whole thing is 180. So 2 times 12 times 7.5 times the cosine of 22.3. Why don't we find the whole thing? We'll subtract.
166.5.
166.5. I get confirmation there.
Yeah.
All right, and then we're going to take this, add it all up, and then take the square root of it. What do we get? That's the square root value. Anyone else getting 5.8 after they add that all up the square root? All right, good deal. So there's the length of our median using log cosines. 5.8. So, law of sines, law of cosines. Preference? Sines, a little faster with proportions, isn't it? A little bit faster. All right, here's our last one. How you guys doing? Any questions so far? Because this is now our tag team. See if we can pair up, come up with a brainstorm here on how to find the perimeter, hopefully you remember what that means, of this parallelogram. All right, we'll come back and revisit. It's only been 21 minutes. Oops. So A was, say it again, sorry, Bradley, what was it?
45 plus 40.
That was the perimeter. And what was this length A?
14.
And what was this length?
8.7.
Will you get out in 2 minutes? There we go.